YouTube, what is up? It's 10 again with another related rates video. This time we're going to be talking about air being pumped into a spherical balloon. So without further ado, let's get right to it. All right, so of course, when you are approaching a related rates question, you always want to remember the rules. And I always say DFDS, which helps me to remember. D is draw. You want to draw a picture of what the problem is talking about. F for formula. You want to find a formula relating the variables together in the problem. D for differentiate. We're going to differentiate that formula with respect to time. And then S, substitute. We want to substitute in the variables that we have and then solve for the unknowns. So our question says air is being pumped into a spherical balloon so that its volume increases at a rate of 100 cubic centimeters per second. How fast is the balloon's radius increasing when the diameter is 50 centimeters? All right, so I like to write down DFDS on the side and check them off, DS, as I go along to make sure that I stay in line and follow my rules. So the first thing I have to do is draw myself a picture. So it says that air is being pumped into a spherical balloon. So a sphere, of course, we know is just similar to a circle with some 3D effects to it, something like that. It says that air is being pumped into it. So here's my nice little air pump. Ta-da. All right. Then it says that the volume is increasing at a rate of 100 cubic centimeters. How fast is the balloon's radius increasing when the diameter is 50? So it's also telling me that this balloon has a diameter, which we know stretches all the way across. That's going to be 50. Now this question is pretty straightforward because it says that we have a spherical balloon and it's talking about volume. So our next step is to decide which formula we want to use. Well, since it says volume and spherical, we know that we can use the volume of a sphere formula. So if you recall, the volume of a sphere is 4/3 pi r cubed. All right, and now that I have my formula, I want to differentiate that formula with respect to time. So the derivative of v with respect to time is just dv dt. So it's going to be dv dt equals 4/3 pi is just a constant, so we're going to pull that out. So 4/3 pi. And then we are going to differentiate r cubed with respect to time. So r cubed with respect to time is just going to be 3r squared dr dt. And if you want to simplify the right hand side, we can go ahead and cross out these 3's because they do cancel each other out. And that will leave us with dv dt is equal to 4 pi times r squared dr dt. So now our final step is to substitute the values that we have into the formula and then solve. So dv dt, which is the rate of the volume increasing, well, we know that they gave us that right here in the question. It says that the volume increases at a rate of 100 cubic centimeters. So I'm going to go ahead and just label that over here. So dv dt is 100 cubic centimeters per second. Then it says how fast is the balloon's radius increasing when the diameter is 50. So notice that they gave us the diameter. They didn't give us the radius, which we need so that we can solve this equation. But recall that if we have the diameter, then the radius is simply just half that. So that would mean that the radius is going to be 25. So the radius is going to be equal to 25. And then, of course, the question wants to know, well, how fast is the balloon's radius increasing when the diameter is 50 centimeters, which is dr dt. That is what that part is talking about. So let's go ahead and make our substitutions and then solve. So we're going to make our substitutions into this equation right here. All right, so dv dt is 100 cubic centimeters, so 100 equals, and then 4 pi, and then r, we said right here is 25, so 25 squared, and then of course we don't know dr dt, that is what we are solving for. All right, so 25 squared is 625, so we'll have on the right hand side 4 pi times 625 dr dt, and I am just going to write this a little bit smaller so I can have some space. dr dt, dr dt, and then on the left hand side we still have 100. So then 625 times 4, well, that's going to be 2500 pi on the right hand side, dr dt, of course, and that's going to be equal to 100. Now I'm going to go ahead and divide both sides by 2500, divide by 2500 pi. So 2500 pi, 2500 pi. This cancels out, of course. And then we have dr dt is roughly 0.125 squared centimeters per second. And that's it. So thanks again for watching. If you have any questions, drop them in the comments below. If you have any questions that you would like to see me work out, drop those down there for me as well. And I will see you guys next time.